And crosshatching is by far the most common and effective method of increasing friction between the punch and aluminum. So there's a few things that make up the basics of crosshatching. And in this video, we'll show you that first, the punch needs to rotate. Second, we need to have diamond media, which is the abrasive, and we need to apply pressure onto the punch surface. And finally, there is a back and forth motion, which you will also see a touchdown and a liftoff point on the punch. There's a number of variables associated with crosshatching, and we're going to go into a bit more details on them in a moment, but from a high level, the crosshatch angle is one variable. Another is the diamond media surface roughness or grade. Another is the application pressure. A variable are the liftoff points, where you touch down onto the punch and where you pull back off of the punch. And finally, operator influence is a variable in the process. So why does crosshatch angle matter? First, to give you a bit of context and let you better understand how we define the angle, here on the right-hand side, we have a zoomed-in image of an actual crosshatch. And this black line here represents the punch center line. So as we refer to crosshatch angle would be between these two red lines here. And when talking about crosshatch angle, a higher angle is good because it provides more friction between the punch and aluminum. But counter to that, a lower angle is better for two reasons. First, it removes aluminum oxide from the punch surface. And so right now, we're going to circle back to these bands around the punch that we identified with the tensile type tear-off. These bands on the punch are caused by aluminum oxide, which is part of the ironing process, and over lots and lots of cans being ironed, small amounts of aluminum oxide can deposit on the surface of the punch. And in essence, the aluminum oxide polishes the punch very slightly. And so if the aluminum oxide is not moved away from the punch surface, bands such as these can appear prematurely. So a lower crosshatch angle allows the aluminum oxide to move away from the punch surface. A lower angle also improves the stripping of the can off of the punch. So what we found is the optimal crosshatch angle is 60 degrees, and it accomplishes all of the things that we're looking for. Good friction characteristics, removal of aluminum oxide from the punch surface, and improved stripping characteristics. Now, why does media grade and application pressure matter? First off, up here, we see various grades of diamond media. They vary in density and the actual size of the diamond media itself. So media grade and the application pressure together determine the punch surface roughness. And the optimal punch surface roughness is 12 microinches Ra, and this is relative to the surface roughness of aluminum. It's approximately half of the surface roughness of aluminum, and there's a lot more details around this, but for a starting place for a crosshatch, 12 microinches Ra is a very good place to start. So why do liftoff points matter? Well, we've already determined that the body of the punch should have a crosshatch surface finish to aid in the can wall ironing process, meaning that we want the aluminum and the punch to move as one with no slipping. What we also know is that the punch nose should be a polished finish, and this actually aids in the dome forming process. So we want one area of the punch to be crosshatched, and we want one area to be polished. So crosshatching too far Just like crosshatching not enough could cause problems, which is why consistent liftoff points are important. Finally, why does operator influence matter? Well, up until this point, we've already determined that consistency is critical. Angle matters, pressure matters, liftoff points matter, and one piece we haven't talked about yet are the number of passes. Because consistency is important, what we want is the same number of crosshatch passes on all portions of the punch. We don't want one portion of the punch to have one pass of a crosshatch media and another portion of the punch to have two, because this could cause a different or inconsistent surface finish. And tear-offs are simply more likely to occur in areas of inconsistent surface finish. Now, crosshatching rather than not crosshatching will give you a much better performing punch. However, if you do have tear-offs, you're much more likely to have a tear-off in areas where you have inconsistent crosshatch. So operator influence simply must be limited to achieve crosshatch consistency. And during manual crosshatching, we know how many variables are involved. The operator during a manual process is always the weakest link of the crosshatch. So IPS provides the X2 crosshatch machine, and we've been selling these for about 8 years. This year, we will sell the 100th machine globally, and it has become the industry standard for performance, consistency, and reliability. This is an automated cross-hatching machine that eliminates operator influence. It has a programmable crosshatch angle. It has controlled application pressure. It has adjustable liftoff points, and we offer various grades of the diamond media.